Hello, ladies and gentlemen. Today we are going to be looking at section number 2 of our test. And section number 2 talks about ratios. Ratios is a very popular concept in mathematics, and I call it the very core of decision science or decision mathematics because it helps a lot in taking a lot of decisions. And we are going to see that as we go through these sections. All right. This is a very important concept that that we need to grasp. One of the concepts that you really need to excel in this course is ratios. All right. So as part of this, we're going to look at how we can write ratios in different ways and how we can interpret ratios with different and same units. And then we're also going to classify ratios as part to part or part to whole, and then scale ratios up or down by multiplying or by dividing, and define and calculate dependency ratios. So we are going to look at dependency ratios, and we're going to look at real world data, right? We're going to look at a data set. We're going to use the US Census data to do our analysis. This is very relevant to our everyday life. We are actually going to look at how you can cook chicken, how you can make pancakes, all right, under this very section. So this is a very interesting section that I want you to pay attention to. Right, let's get it going. Now, here, so we are going to, let's do this discovery. A specific brand of flavored sparkling water is available for purchase from Amazon. The water can be purchased in multi-packs. The options are listed in a table similar to the one below. So this is the options we have available. So we have 3 flavor packs, which is 18 cans, and then we have 8 flavor packs, which is 24 cans. Now, this is the costs, the whole cost of the 3 flavor, and then the whole cost of the 8 flavor pack. Now, this means that 0.56 per count. All right, so this is the unit cost. All right, and this is the unit cost for the 8 flavor pack. Now, we want to look at what does the dollar per count mean and how is this determined? The dollar per count, it is the price per can. And very soon we're going to realize that per is a ratio term. It means division, and we're going to see that very soon. So it is calculated by dividing the total price by the number of cans. So if you went to the grocery store to buy anything and you want to know the cost per can, the unit price, all right, just divide the whole cost, all right, by the number of quantities you have in that particular item you want to buy. Okay, good. So ratio is a decision science and helps us to make decisions. Now, a ratio is a comparison of relative size of 2 quantities. All right, so here, this is how we did the math, like I said. So this is how we came by the unit price. Now, based on the price, the unit prices of the 2 available options, this is where we decide which of this is a better buy. All right, and we are going to decide that because this option charges less money per can, it is the better buy. All right, so this is a decision that has been made out of ratio right here. All right, so you did the ratio, then you realize that this is less compared to the 3 flavor pack. So your decision will be to take the 8 flavor pack because that's a better buy. Good. Nice. Now, what happens if the ratio was flipped upside down? Now here we are going to realize that the order of the ratio is very important. So if you flipped it, you made a mistake, you flipped the cans per cost, you are going to have a different choice, and that wouldn't be the right choice. So order of a ratio is very, very important. Now, what I want to avert your minds to, let's pay attention to this. So if I have 1/2 and I flip this to 2/1, the results are different. 1/2 will give me 0.5 and 2/1 will give me that. So the results are not the same. So the order of a ratio is very, very important. All right. So yes, the order really matters. Is that okay? So you have to be careful how you do your division. Right. Now, these are different ways that ratios can be represented. Ratios can be written with a column, with the word to, with the word per, and as a decimal, as a fraction. So 3:2, 3:2, 3/2, 3/2, and 1.5. These are different ways you can represent a ratio. And we are going to see that very soon. Now, so here, there's a very simple exercise that I want us to practice. So if I have 12:15, so it's written as A is to B. We want to write that as A to B. All right, so it's pretty simple. Is that okay? Because these are different ways. So we'll just do 12:15. And if you want to reduce that fraction to its lowest form, that'll be 4/5. Now, as a reduced fraction, it will just be 4/5. And now as a decimal, just take your calc and punch that, and that gives you 0.8. So here we are given 5/4. We want to write it right here as what? Using h2, right? So we are just going to do 5/4. And then as a reduced fraction, this cannot be reduced further. So we still have 5/4. And as a decimal, we have 1.25. Okay, so here we start from this point. We have 22:5. We want to write it as A to B. A to B, all right, 20/5. And then as a reduced fraction, okay, that's just 4/what? 1, which is 4. And then as a decimal, okay, that is also 4. Now we have 7/3. And we want to write that as A to B. So our A is 7 and our B is 3. So we want to do 7/3. And as that and as a fraction. So this sign you see right here means that 2.3333. That means repeating, right? So in some books you see 2.3 and then they put this symbol, or you can see 2.3 and then they put that. That means that 3 repeats itself. Is that okay? That's right. Good. Nice. Now here, we want to complete the table round decimal answers to the nearest 100. Is that okay? Now, it's pretty simple. All right. So here, we have 9" to 3 feet. Now, the good thing here is that one of these, to reduce fractions, to write these as a reduced fraction, you need to change from one unit to the other. Is that okay? So we are actually going to look at a whole section. When we get to section 13, we're going to look at unit conversions, and we will know how to do this. So for now, I don't want to bother you with how the conversions come about, but it's pretty simple. You're aware that you can change from inches to feet and back. All right. So we use the same unit. So make sure if there's a possibility of you to change these to same units, make sure you do them, right? You do that and then you reduce them. Okay, so we know that 1 hour is 60 minutes. So that will give us what? 3/5. And as a decimal, now 3 weeks to 3 days. All right. So the unit conversion is that we know that 7 days is equal to what? 1 week. So if you have 3 weeks, we have 21 days right there. Now we reduce that and we have 7/1. Now, all right, 75 cents to $3. All right, now if you know that 100 cents will give us $1. So $3 will be 300 cents, and we reduce that, and we have that as a decimal. Is that okay? So to make sure to reduce fractions to their lowest form, it is always advisable to make sure that the units on both ends, okay, of the division sign are same. Is that okay? Sweet. Now, in my regular class, I use this term a lot. I ask my students, if you hear Gucci, Gucci means that, are you okay? Is it good? All right. So I'm going to be saying Gucci a lot. So if I say Gucci, Gucci means that, are you okay? Do you get it? Do you understand? Stuff like that. Now, let's look at this example. In movie cameras, 35mm film was shot with an aspect ratio of 4:3. HD TVs have an aspect ratio of 16:9. Are these ratios same? So what we want to mean is that we want to do this ratio 4:3. The question is 4:3 the same as 16:19? That's the question we have. So this is a question mark I put right here. What our goal is, are these the same? Okay, and we are going to realize that these are not the same. So really, in effect, this means that we want to compare if 4/3 is the same as 16/9. And we are going to realize that these two fractions are not the same. Is that okay? So if you reduce that, it will never give you 4/3. Is that okay? So be careful. If you want to reduce that, make sure you have the same number going into 16 and going into 9 to say that they are the same. So these two are not the same. 4/3 is not equal to 16/9. Okay, sweet. Okay, so this is just a bonus slide. Something fun, right? It's not the same. Right. Now, you may have a friend called Jane. So Jane makes $10.5 per hour, and Lee makes $12 per hour. We can make these comparisons all the time. We have friends at home who make certain amounts. All right. Now we want to write the ratio of what Jane earns per hour to what Lee earns per hour. Now we have already established that the order of a ratio is very, very important. So our goal really is that we want to do how much Jane, okay, my pen is misbehaving. Let me get it right. How much Jane makes per hour to how much Lee makes per hour. That's our goal. It's not Lee over Jane. It's rather Jane per Lee. Is that okay? So we know that Jane makes 10.5 per hour to Lee. Lee makes $12 per hour. So we want to write that as a fraction, and that is what we have right there. Is that okay? So that is a reduced fraction as a fraction. Now, how did we do that? You can do this accurately if you wanted to get this fraction. So here we have 10.5 and we have 12, right? You remember how we dealt with equivalent fractions. If I want to change this to a whole number, I'll multiply, because this has one decimal place, I'll just multiply that by, I'll multiply this right here. So you multiply 10.5 by 10, and that is 1/5. That is 105, sorry, 105. And then I'll multiply 12 by 10, and that will also give me what? 120. Now, when we reduce that, that will give us the reduced fraction of that, 7/8. Is that okay? Sweet. Now, let's go as a decimal. So as a decimal, just put that on your calc, and that gives you the decimal form of the number. Is that okay? Sweet. Now, write a meaningful sentence using one of the ratios. And as part of this class, you have to know how to interpret your results. Is that okay? Very, very significant. Is that okay? So what this means is that we're going to have 3 different interpretations for this. Now, Jane makes 7/8 of what Lee does. And For every $7 Jane makes, Lee makes $8. And if you want to look at it percentage-wise, you see Jane makes 87.5% of what Lee does. So these are three separate interpretations you can make. Either of these is right. Is that okay? So this is how you interpret this fraction. Is that okay? Sweet. Now, this is here where we learn how to make pancakes. So here, we are going to know, how many of us know how to cook, how to make pancakes? All right, let's see how you do that. If you don't get this right, you are exposed. You don't know how to make pancakes. Now, a recipe calls for 2 cups of milk for 2 cups, 2 cups of milk for 3 cups of pancake mix. Now, what is the ratio of pancake mix to milk? Look at it closely. Pancake to milk. Is that okay? Does that ring a bell? So we want pancake over milk. So that is just, all right, 3:2, not 2:3. The order again is very, very significant. Now, this recipe feeds 4 people. Now we want to scale up this ratio, okay? So that this recipe can feed 16 people. What we do, we multiply that by 4. Okay, now this can feed 16 people. And that is scaling up. Is that okay? So this feeds 4 people. So if you want to make it, scale it up to feed 16 people, you just multiply that by 4. And that gives you the ratio. All right. So even in cooking, you realize that ratios are very, very significant. All right. If you are making your tea or you're making a coffee, I have a coffee right here. If you don't do your ratios right, your coffee will not taste good. Either you have excess sugar or less sugar. All right. If you're making rice, I like to make rice, and you don't get your ratios right, you end up getting a rice water. All right, so be careful. Ratios are very significant, and they are used in everyday life. Now, right, so the ratios cancel out. Now, in the following example, we want to look at how we can interpret. So we write as a reduced fraction, as a decimal, and then we interpret. So this example has been done for us. So 12 apples to 8 oranges, okay? So if you reduce that, you have 3 out of 2 as a decimal, you have 1.5. These are the 2 interpretations you can make for this relationship. There are 3 apples for every 2 oranges. And then you can also say there are 1.5 apples for every 1 orange. Okay, let's look at that. So for ducks, 44 treats to 8 ducks, you reduce that as a decimal, and then these are the interpretations. All right, reduce that, all right, and these are the interpretations. Okay, so interpretations are very, very significant. For this class, almost every problem you solve at the tail end of the problem, you'll be asked to interpret. And that is what quantitative reasoning is about, because we want you to understand the numbers that you are turning out. Okay, we are just not interested in the answer, but we want to make sure you understand the numbers. Okay, good. Right. Now, here we're going to cook some chicken. All right. So the local firehouse cooked 780 pieces of chicken for an estimated 240 people coming for their fundraiser. Now, what is the ratio of chicken to people? So you have to do the math. All right. So when you have a party, you are expecting some number of people, you have to be able to do these breakdowns. All right. Okay. We're going to make sure we feed every person with 2 drumsticks of chicken. All right. So you have to do the math to get your estimate right. Is that okay? So you have that, and there are 3 1/4 piece of chicken per person. So you have to do the estimates before you go shopping. Is that right? So that you don't waste money. You don't have excess at the end of the day that goes to the garbage. Nice. All right. So there are 6.6 million people in Indiana, and the area of Indiana is 35,826 square miles. What is the ratio of Hoosiers to square miles of area? Now, use this answer in a meaningful sentence. Okay. So what is the ratio of Hoosiers to square miles? So Hoosiers, that's the population, 2 square miles. And that is approximately. So this symbol you see right here means approximate. This is an approximate symbol. So there are about 184 Hoosiers per square mile in Indiana. All right. Here, we are also going to learn to choose right. You go to Walmart, you want to get some detergents. All right. So now you have to do the math. You know, when you go to the grocery store, there are a lot of options to choose from. So you have to pay attention to the volume of detergent you have and the cost. And you can do the ratios right there and then make a better choice. Is that okay? So here we are going to do that. So you have to do the ratios. So you look at the cost for 100 ounce, all right? And then you do the cost for 150 ounce, all right? And you are going to realize that the 150 ounce option is a better buy, okay? So when you go to the store, make sure you do these numbers before you make a choice. Good, so that you can save some money. Right, now you may want to take a break. You know, the good thing about videos is that you can always pause the video and take a break, all right, and come back. Is that okay? So in my regular class, after every 15 minutes, we will take a break and then we resume so that you can freshen up. So you can pause the video at this point and come back. Nice. So let's continue. Now we have what we call part to part and part to whole. So part to part compares two things based on their differences, and part to whole compares two things to the entire lot. Is that okay? Now I'm going to make a case. I'm going to let you understand this in a very simple term. So we're going to use a class. So assuming in this class we have 26 students, where there are 26 men and 10 women. Now the ratio of men to all the students is 16:26. All right. We could also say 16 out of 26 students are men, or about 61.5% of students are men. All right. Now, let's look at it. Now, in the example above, what is the ratio of women to the whole class? So women, we have 10 women, and the whole class is what, 26. So that will be what, 10 out of 26, and that will be reduced to 5 out of 13. Now, can the ratio be written as a percentage? Yes. And we learned how to change from a fraction to a decimal and then to a percent. So 5/13, put that on your calc, that will give you a decimal, and then you multiply that by 100 to give you the percent. Okay. Yes, it is a part to whole, so can easily be expressed as a percentage out of the whole. Okay. Now, is the ratio, we want to put that ratio in a meaningful sentence, and then you say that about 38.5% of the class are women. Is that okay? Sweet. Now, let me clarify this a little bit. Let me explain to you what part to part is and part to whole means. Now, part to part is that if I compare a part of the class to another part of the class, there are two parts of the class. We have men and we have women. So if I compare men to women, I'm comparing two parts. So that is a part to part. Is that okay? If I compare a part, so if I compare women and the entire class, that is a part to whole. If I compare men and the entire class, that is also what? A part to whole. Is that okay? So this is how you're able to decide to determine whether you're doing a part-to-part analysis or you're doing a part to whole. So if you're comparing a part to a part of the class, that is part to part. If you're comparing a part of the class to a whole, to the entire class, that is a part to whole. Okay, and we're going to see most of that coming up. Gucci. All right, sweet. Now, the population of North Korea is estimated to be 25 million people, whereas the estimated population of South Korea is 51 million. So NK and SK, right? Now we want to write the ratio of NK to the ratio of SK. Order is important. All right. So you do 25 million over 51 million, and that gives you what? 0.490. Now, can the ratio be written as a percent? We could state that NK's population is 49% of South K's population, right? But there are probably less confusing options. So we look at that. Now, interpret the ratio using a meaningful sentence. And this is a very meaningful, you can do this in different ways. So what this means is that there are 49 North Koreans for every 100 South Koreans. So how did you do that? We did that by dividing this by 1. We know every number is over 1. So we want to compare that in 100 population. And that is that, okay? So you have 49 out of 100. Okay, so this means that for every 49 North Koreans, there are 100 South Koreans. If you wanted to make the population out of 1,000, we just had to multiply this by 1,000. So you say that for every 490 North Koreans, there are 1,000 South Koreans. You could do it for 1,000,000, for 10,000, for 100,000. And all these are accepted. Is that okay? Sweet. Now, let's look at this data set. Don't be intimidated. It looks very simple. So analyze, look at the table closely. So this is employment status, less than high school diploma. We have high school graduate, some college, no degree, and so on and so forth. So civil labor force in thousands. So these numbers are in thousands. Pay attention to that. And unemployment, these numbers are also in thousands, and these are the rates, unemployment rates. So we are going to do the analysis right away. Now, the unemployment rate is a ratio of number of unemployed to the number in the civilian labor force. Okay, so unemployed, okay, to the number in the civilian labor force. So be careful. So this is unemployed and this is the civilian labor force. Now, the first question, is this a part to part or a part to whole ratio? Think about it. So this is a part to what? To whole. Is that okay? Sweet. Now, what unit should be added to each of the value in the unemployment rate table? And that is a simple question. It's just percents, right? And the appropriate units. Okay, so the next one, so we added the right units. So that is a part to whole. So you just had to do this over that, this over that, that gives you that, this over that gives you that, this over that gives you that, this over that gives you that, and so on. Okay, sweet. Now, consider the values in the civilian labor force role of the table. Could we approximate the number of civilians in this labor force? If so, what is it? So that could be approximated because these numbers, again, don't forget, these numbers are in thousands. And you are going to see these kind of data sets a lot for this course. Okay, nice. Now, find the ratio of people with some college, no degree in the labor force to the total civilian labor force. Total civilian labor force. Okay, and that is what a part to hold. All right, nice. That is a part to hold. So to the total, so you have to put all these together and divide. Is that okay? Good. So put all that together. So add that, add that, add that, add that. So this guy over the sum of everything. Now interpret the ratio, and approximately you have 16.7% of the labor force has some college but no degree. All right, good. And this is a part to part, and you have the ratio as that. Sweet. So now we know what part to part is, and we know what part to whole is. Very significant part of this section. Okay, very, very important. You have to know what part to part is and what is what part to whole. And that is a very good thing to know for this section of our course. All right, now we want to compare the two graphs, sorry. Why do the bars follow different patterns? All right, so you realize that the unemployment data for the first graph, these are just actual numbers and these are percentages. Okay, so that is why the bars follow different patterns. Okay, in the two graphs. So really, the two graphs represent the same thing, except that the bars are different in both cases because one has percentages and one has the actual numbers. All right. So you realize that as you see in this graph, this should tell you that the higher the educational attainment, the lower the unemployment rate. All right. Right. So this is it. So these are some of the conclusions you can make out of this graph. All right. Now we talk about something very important. Okay. For this section that talks about age dependency ratios and describe the relationship between that. So here, look at the table closely. Now it says that population by age and sex 2011, number in thousands. So these numbers you see right here are in thousands. Now consider the following data from the US Census. So this is a data from the US Census Bureau for 2011. Now let's see that. So now, so ages 0 to 14, if we put the ages 0 to 14 together, we have a total of that. We put the ages 15 to 64, that gives us that total. And then 65 and older gives us this total as well. Okay, now, and if you put everything together, you have a grand total of that. And don't forget that this is in thousands. So this number, as you see, really is in millions. Because if I add it, if I make this 1,000, this will be the total will be 306,108. I add 3 zeros because it's in thousands. And I have 306 million. Okay. So these are estimates, right? Now, what is the population according to that? And that is the population, and that is about 306 million. Okay, now calculate the age of under 15. So under 15, that is what? To the total is a part to whole, right? And interpret. If you want to interpret that, you say that 20.3% of the population is under 15 years of age. Okay, now I want you to pay attention to this, and we're going to look at 3 different dependency ratios. So the first thing we're going to look at is child dependency ratio, which is found by dividing under 15 by 15 to 64. Okay, so that is how you find child dependency ratio. So you want to know the ratio. All right, so let's see how this is done. And this is a part to part because that is our child dependency ratio. Now we want to do that. And these are the numbers. So here you do 62155 divided by 15 to 64. And this is very commonsensical. We want to know the percentage of people who are kids and who depend on the active group of people. So the middle group, I call them the active group. All right. So 0 to 14, somebody takes care of you, right? And then usually at retirement, 65, there are people who are 65 and older who take care of themselves. But really, if you go to nursing homes, people who are younger take care of the older, right? And these are the ratios we want to churn out. And these are used by statisticians to determine, the population, the various defects and what the population we need to focus on as a country. Okay, nice. All right, now we want to look at old age dependency ratio. Now you realize that people who are 65 and older, they depend on people, they don't depend on people who are 0 to 14 because they are also kids. They are kids, they depend on other people. So this group of people depend on that group, 15 to 64. So, and that is how we do that. So divide age 65 and older by people who are 15 to 64. And that is a part to part. And you want to do that and you interpret that as such. Is that okay? So first we look at child dependency ratio. Now we just look at old age dependency ratio. And then finally we look at age dependency ratio. Now for age dependency ratio, what we do is we put the two dependent groups together and divide by 15 to 64. All right, the number of people in that group. And that is that. So you put the two together and that gives you people who are dependent in the economy, in the country. All right, now you do that and that is a part to part. It's still a part to part. Now, this gives you, this ratio represents the number of dependents. So people who are dependents, each working age person must support addition in addition to themselves. Is that okay? So you see there are 495 age dependents for every 1,000 working age people. Okay. So basically, this is the economic interpretation, which is more desirable, economically desirable, a high age dependency ratio or a lower one. Now, the higher the dependency ratio, the larger the number of dependents relative to the number of working age people. Now, in an economy, all right, we expect that people who are active and working should be more, right? So that we can generate more income or more taxes for the economy. So if there are more dependents than people who are working, the working age people, there's a lot of burden on the working age people, right? Because the revenue of the economy reduces. All right, so these have economic implications, and it's very important. Now, on the flip side of this argument is that lower dependency ratio means the working age group is larger. Now, in what ways can lower be bad? The other way lower dependency ratio can be bad is that means that there are more people in the economy who are active and looking for jobs. All right, so there's competition. There's very high competition for jobs. Okay, so that is good, right? When we have more people who are active and looking for jobs, that's equally good. All right, so this is an analysis, a further analysis dependency ratio. Okay, these are projections we want to look at between 1950 to 2080. All right. And this is what has been projected to happen. Now, what do you see? You see a convergence getting to the tail end of this graph. And this is really very serious, right? So what do you see? Old age, okay? Older persons, and then we have kids. Now these two lines are meeting. And what do you see for all dependents? Okay, that is rising. So we have to be careful. These days, people are not giving birth, and these can give us a lot of implications. So if you really look at this closely, it says a lot. This graph really says a lot. So look at it closely. Okay, so you look at the baby boomers. Baby boomers are people who were born after the Second World War. And most of them are aged now. They are old, able to work. All right, good. So these are inverse dependency ratios we want to look at. East Asia, USA, Sub-Saharan Africa, South Asia, Europe. All right, so we just want to look at these. We want to explore further and see how we can analyze this. So if you pay close attention to this, it's quite self-explanatory and it helps you, okay, to understand stuff. All right, now these are practice problems, and I'm going to give you these answers, right, as a reduced fraction, as a decimal, and then the interpretation. And these are just practice problems, which I, as part of your book, I'm giving you. So try them on your own before you take a look at the answers. Okay, good. So basically, that is all this section is about. Let me give you a quick summary of stuff, what we have discussed so far. Okay, let me give you a quick summary of what we just looked at. Okay, and of importance to me, I am going to pay attention to the dependency ratio. So we've looked at the various ways we can write. So one, we've looked at how ratios can be established, or how ratios can be written, and we realized that you can do A is to B. All right, A to B. And we looked at as a fraction A over B, and then as a decimal, finally. And then number two, very significant, we looked at the dependency ratios. Is that okay? So the dependency ratios, first of all, we looked at child dependency ratio. And child dependency ratio, what we said was that ages 0 to 14, okay, these are ages, the number of that divided by people who are 15 to 64 age group. All right, and then we looked at old age dependency ratio, and we said that is what old age is 65 plus ages divided by the same group of people. Is that right? That's how you do it for old age. Okay, let me clear that, and then we look at the last one. And then we look at the last one, which is age dependency ratio. And age dependency, you put 0 to 14 ages plus the other group of dependents, 65 and older. And these are the numbers, ages, and then you divide by the same group of people. So you realize that this is the active group, and this group of people work a lot. All right. So you realize that the similarity is that you always divide by people who are ages 15 to 64, and the other working group. All right. So that's all we've looked at for ratios. And we also realize that ratios can really help us to making decisions, making good choices when you want to go to the grocery store, you are in business, okay, whatever endeavor you are. If you even want to cook at home, you need some ratios, all right, to do that. So thank you and enjoy your day. Thank you very much.